Hola. And unfortunately, that's where my Spanish ends. So thank you all for listening and for being willing to listen to a very wonderful translation. I think the translators in the back are doing an absolute fantastic job. So thank you to them. And also thank you to Paul and Edgar and Jorge for inviting me here to ElastixWorld. This is my first ElastixWorld. It's a fantastic conference. I've had an absolute wonderful time. And I'm really excited to be here to talk to all of you today about Asterisk, about where the Asterisk project has been, and where we think the Asterisk project is going. I will say this talk is kind of two parts. The first part is really a retrospective on the history of the Asterisk project and how it fits into what we've seen happening in the industry. And then the second half is really focused on what is happening in the industry today and how we are adapting the Asterisk project to meet the needs of both existing systems as well as the systems that we believe are going to be built in the future. One last word of caution before I get going into the presentation. When I get excited, I tend to speak faster and faster and faster and faster and faster and faster. And so if I do, somebody in the back just wave their hands and I'll slow down to let everybody catch up. And hopefully I'll be good with my pauses. So the Asterisk project has been around for quite a long time. It was started in 1999 by Mark Spencer, which means we have 17 years of history, almost. Pretty close. Almost, yeah, about 17 now. When you look at the history of the Asterisk project, there are milestones. There are certain key points in time in which the Asterisk project pivoted and adapted itself to what the industry was doing and what the user base needs. And so in the first part of this talk, we're going to look at some of those key points in the Asterisk project history, as well as what was going on. And I like to divide the Asterisk project history into sort of key phases. And the first of these is what I like to call the early years. And it's really from the first release of Asterisk 0.1.0 till about Asterisk 1.4. Funnily enough, when you get back into the really early years in Asterisk 0.1.0, which was released on December 5th, 1999, this is a very challenging thing because there's no history. When you look at the commit log in Asterisk, eventually all the commits just sort of disappear and turn into uploaded from FTP. And so whenever we have to understand why a code change was made, if we actually have to go back this far, and there are some lines of code that still exist from this time period, we get very concerned because we have no idea why they were made. We ask Mark, and he says, I don't know either. We did things. So it's kind of an archaeology thing. So if you look out on the internet, you will still find, however, Mark's original announcement for Asterisk on a mailing list, in which he announced, congratulations, I've released to the world Asterisk 0.1.0. What else was going on in that time? Well, the most evil organization that currently exists, as Saul reminded us, was actually in beta. This was Google for everybody at that point in time. And for most of us, this wasn't even how we searched the web. If you were me and just barely a college student at the time, this was the internet. This is how I searched. Alta Vista, right? But for many people in North America, this was the internet. And by the way, this was terrible what these disks did to the environment. There are whole landfills in the United States filled with these disks. How we viewed the internet hadn't even really been defined yet. It wasn't until the year 2000 when we actually had the dissertation that coined the term REST. And so this was actually the front of the dissertation that was given by Fielding where the term REST actually was coined. And prior to this point, we didn't even have a definition or a specification for the APIs that really form the modern web. At this point in time, we would have been building SOAP APIs or XML RPC APIs. But this actually postdates the first version of Asterisk. But of course, Asterisk wasn't anything that anybody in this room would probably recognize either. There were no APIs in Asterisk at that time. There were only 6 dial plan applications. That's it. That's all you could do with the channel when it was created. And as far as channels are concerned, there were only 2 channel drivers: voice over frame relay for ADTRAN devices and a channel driver for QuickNet cards. So there was no true VoIP protocols that we think about. There was no integration, really. The integration with the PSTN was, and it was a very small version of what we have today. In fact, if we look at Asterisk as sort of a 50,000 foot view architecture, we have very little components in it. There was a 1 PBX core for everything. There were no alternate languages. There were only those 6 dial plan applications, including dial and playback, but no conferencing, no call queues, no parking, no features. You had only the 2 channel drivers, and the only real device that we talked to was an ADTRAN Atlas, and that was about it. And that was the first version of Asterisk. That's really where we released it into the wild. 5 years later, we finally reach 1.0.0. I like to use this as sort of a teaching moment for anybody who comes to me and tells me they want to start an open source project. Everybody says, wow, Mark was so successful with Asterisk, and Asterisk has had this amazing success, and I always remind them, he spent 5 years to get to 1.0.0. In order to have the Asterisk that really formed what we would think of Asterisk today, it was 5 years of development. This was not a quick process. But it was released at the first AsterCon. Well, in that time period, the world changed again as well. Google began its inexorable march towards domination. And they IPO'd in that same year. What else happened? Well, the Facebook. And so the entrance of social media into our lives began. Social networks existed prior to this point, but they really hadn't yet permeated our lives to the extent that we began to see at this point. Interestingly enough, Linux was changing along with it. The first version of Ubuntu released from Canonical was in the same year, Warty Warthog. And so what we even started to think about where you go deploy Asterisk began to change. But probably the most fundamental thing that changed by that point was, of course, a little RFC called 3261, released in June of 2002, around that same point in time. I always think it's funny, Mark being the very amazingly fast hacker programmer that he is, the RFC was released in June 2002, and Mark had the first version of ChanSIP done by the end of that month. He moved fast. And so if we revisit this architecture of what is Asterisk, we start to see a lot of the components that make up Asterisk today. You have some channel drivers that we start to recognize: ChanSIP, ChanZap, which of course, thanks to Jim Dude Nixon of Zapata Telephony, was the real first channel driver that allowed us to integrate with PRIs and analog and all the other sort of traditional telephony components. We have more dial plan applications, sort of the large dial plan applications that form the fundamental components of Asterisk: AppDial, AppQ, AppMeetMe. We finally have codecs and formats in their appropriate place, and we have a pluggable architecture to allow codecs to be added. We start to see billing integration with CDRs and with databases. And we have the first 2 APIs added to Asterisk: the Asterisk Gateway Interface, AGI, and the Asterisk Manager Interface, AMI. And this begins to allow some external things to be built on top of Asterisk around this point in time. So let's fast forward a little bit further. First release that really became massively widespread, Asterisk 1.4, released in 2006. So now the Asterisk project has been in existence for 7 years. Google acquired YouTube, so now video is becoming more important and showing up in more places. We have the first tweet. I don't know about the people in the audience. I've been on Twitter pretty much this entire conference. I don't know if I could ever attend a conference without Twitter at this point. But again, we start to see more social networks, more things being introduced. And it really, at this point, Asterisk was solidifying itself just as a PBX. I would say in this instance, this is one of those times in which the world was beginning to change what is the notion of the directory, change the way people consume media, and Asterisk really kind of kept going down the PBX path in this particular case. But we do add more functionality. You now have dial plan functions. Those are useful because they allow you to access dial plan primitives through APIs. You get more enhancements to the PBX core, different languages like AEL and Lua. The APIs begin to become more advanced with more functionality being added to them. And people begin to build really large, complex systems on top of Asterisk. Systems like Elastics. Elastics, I believe, actually existed before this version, but certainly this is where you start to see more systems like Elastics being built upon Asterisk as an engine. This takes us into the Asterisk, the middle years of what I like to call it. So really about version 1.6 through about Asterisk 11. Interestingly enough, during this time period, there were a lot of refinements being done inside the Asterisk core that didn't really even see the light of day in this period. During this time frame, we laid the groundwork for a lot of new architectures inside of Asterisk. This is where the bridge framework that we actually use extensively now today was first written. We added a dialing framework, which again ended up being very useful for some new APIs that I'll talk about in a little bit. And we added wideband audio. And so there were a lot of core infrastructure things that were done in Asterisk that maybe not everybody who used Asterisk could see, but it really laid a foundation for what comes next. So Asterisk 11, one of the current LTS releases, which is almost about to go out of support, but that's okay. But it was released in 2012. One of the most important things that happened around this time is something that probably not many people even know exists. One of the main goals of the Asterisk project around Asterisk 11 was to really improve the ability for us to make releases and have functionality continue to work. That's sort of important. It's sort of what people start to expect when you've been around for 12 years is that, hey, if you make a new major version, can my functionality continue to work as I need it? In order to do that, we created an entire test suite that's built, that tests and exercises Asterisk. This was actually the first commit that was made to the test suite by Russell Bryant at that time. Today, every night, 1,484 tests execute against Asterisk. They cover all SIP functionality, application functionality. They exercise the APIs. They do stress testing against Asterisk. We actually have a test that creates a chain of 300 local channels and then optimizes them down into one. And we just do it to see if we can still actually do 300 channels in a chain sequentially to see if they'll all collapse. But it was because of this testing effort that began at this period of time that the stability of Asterisk and the reliability of Asterisk really began to mature. And that was extremely important because we wanted people to be able to upgrade to the latest version of Asterisk and have confidence that some basic level of functionality would always work, no matter what. Around this time as well, we saw WebRTC, and WebRTC just turned 5, which is kind of shocking. So the first initial support, limited, for WebRTC was introduced into Asterisk and Asterisk 11 as well. And so you could start to add browsers that could actually talk to Asterisk and have more functionality, more endpoints that are communicating with Asterisk. And again, though, the architecture of Asterisk at this point was relatively fundamentally a thing. It didn't change much between that 1.4 and 11 timeframe, even though we had done some pretty substantial work in the core of Asterisk. We did have more integrations by this point. You can integrate with remote calendaring systems, with speech recognition engines. You can integrate with XMPP servers as a way to share device state and MWI between clustered Asterisk instances. But a lot of this stuff was refinements on top of the existing technology. And that takes us, of course, to the present, which really begins with Asterisk 12. I'm going to kind of blend some of the discussion of Asterisk 12 and Asterisk 13 at this point. Asterisk 13, first LTS release that was based on a new architecture that was introduced in Asterisk 12. So why did we bother making a new architecture, though? Why did we fundamentally invest into the core of Asterisk? Well, at AstraDevCon, which is a developer conference that's held at AstraCon every year, in 2012, the community really pointed out that we had two issues in Asterisk that we really needed to address. We needed a new SIP stack, and we needed new APIs. Why did we need these things? Well, we decided we needed a new SIP stack because ChanSIP, although venerable and had serviced untold trillions of calls, was never really designed, period. It grew organically over a period of a decade. And as a result, it went from being a relatively reasonable set of functionality to 35 to 40,000 lines of C code with not a lot of structure. And so it was very difficult for us to continue to enhance and extend upon it. Things that I know have frustrated a few people I've talked to this week. Things like how Asterisk interprets DNS records ends up becoming very complicated due to the architecture and design of ChanSIP. ChanSIP wasn't designed to understand that a DNS entry may be asynchronous or may return multiple records. And it really just runs aground into its core function. So that was one problem. We wanted to provide a better SIP experience. As far as we're concerned, SIP is the de facto VoIP protocol, and we need to have a good implementation of it. The other focus that we decided we needed to work on were our APIs. Now, that's interesting, right? Because people had been building large systems on top of Asterisk, and they'd been doing so very successfully. However, if you've ever built a large system on top of Asterisk, you know that Asterisk does some weird things sometimes. Whenever you transfer a channel, for example, if you're listening via AMI, you'll see a very weird sequence of events where there will be a rename, and then another rename, and then this thing called a masquerade. This makes it very difficult to understand what the state of the call is inside of Asterisk. And so we wanted to provide a cleaner definition for what was happening to channels inside of Asterisk. And then we wanted to provide a new API that allowed people to build their own custom communications applications on top of Asterisk. I'll show a little bit of that. So the PJ SIP stack today, this is another very high-level view of it, is actually made up of a large number of modules. It's a stack that can be customized based on what you want it to do. Today, there's 47 modules in Asterisk that make up the PJ SIP stack. That allows us to add new functionality without harming or otherwise possibly perturbing the existing functionality. As an example, when we needed to add integration with Homer, which is a SIP capture server, we didn't actually have to touch any of the existing modules. None of the code in the existing modules had to be altered. We wrote a new module that allowed it to sneak the traffic off to Homer, and it just plugs into the stack. That makes it much easier to add new features and to extend the SIP stack in Asterisk. The new API that we added, called the Asterisk REST Interface, ARI, allows people to build custom communication applications on top of Asterisk. The key way in which this is done, though, is because we wrote our own internal pub/sub message bus called Stasis inside Asterisk. And what Stasis did is it separated out the state in Asterisk from the APIs that are trying to expose it. So when I have a channel, and that channel is answered, and it has a new state, it broadcasts a message internally that says, this channel is now answered. That state can then be replicated across the Asterisk Manager interface, across ARI, and across any other API that we choose to go develop. That provides consistency across all the APIs that are built on top of Asterisk so that you always get the same view of the world depending upon which API you're using. The other flexibility in that, however, is that it also allows us to custom tailor the view without impacting the core. So for example, in ARI has a subscription-based model for events. You subscribe to particular events that you'd like to see, unlike AMI where you have a fire hose and everything comes to you. Because we are managing those subscriptions there, we can choose which events we propagate out to the external applications. Why is this interesting? Well, this is interesting because this is a conferencing application on a single slide. And this is what ARI allows you to build. ARI exposes the fundamental primitives inside Asterisk that the C developers use to build applications. And so I can create a bridge through a RESTful interface, and I say that my bridge type is of type mixing. And then when a channel enters my custom communication application, I get notified, I answer it, and I add it to the bridge. And the bridge will automatically pick the best mixing technology based on which channels get put into it. You'll note I didn't have to move channels into a conference or move them around in order to get in the dial plan in order to put them in here. I'm just given the channels and I have full control over it. Some other interesting things about ARI. These exist today. We all know that Asterisk can use databases as where it pulls its configuration for SIP channel drivers, PJSIP, ChanSIP. That's fine, and that works for a lot of applications. But there's a couple downsides to always using a database for everything. One of the downsides is that whenever you update the configuration in the database, you often have to poke Asterisk and tell it to reload. Well, if you have to go poke Asterisk anyways, why don't you just hand the configuration to Asterisk? And so the REST API actually even also allows you to inject configuration into Asterisk via JSON. And so here I'm actually creating a new PJSIP endpoint called Alice, and I can just post it directly into Asterisk, and the next time a request comes from Alice's phone, it'll just show up there. If I need to move Alice's phone to another server, I can delete it off this one and post it off into another one. There's no reloads, there's no prune peers or anything else that has to happen. This is also possible because of a lot of the APIs and frameworks that we built into Asterisk in more recent versions. So the way this works, if I posted the endpoint Alice into Asterisk, it hits our embedded HTTP server. ARI then interprets the request and understands what that HTTP request is supposed to be. And then ARI asks a very funny framework called Sorcery, which is a data abstraction layer, to go ahead and store the object. Why is this called Sorcery? This is what happens when you let developers name things. He thought it was kind of magical, and so he called it Sorcery. Joshua Culp. So when Sorcery gets the request to store the object, it actually can choose a hierarchy of backends to go store that object either temporarily or permanently. In this particular case, I've configured it to have an in-memory cache as well as to go ahead and cache that object into the AssDB in case my server restarts. So if it restarts, I still have it. So I put Alice in both places, in the cache and in AssDB. When a request arrives for Alice into ResPJSIP, ResPJSIP goes and asks Sorcery for Alice and uses the one in the cache because we have one in the cache and it hasn't expired yet. And then it goes ahead and creates a channel for Alice. One of the reasons why we ended up using this for some systems and other people have used this is because when you're building a larger system on top of Asterisk, a phone is not just the configuration inside of Asterisk. A lot of times there's a lot of other configuration data that goes along with a phone. Who owns it? Where is its location? What other metadata properties might I have about it? Is that phone associated with a location? Is it associated with a user? And because people are already building systems to manage this configuration, we now allow them to fully own the configuration and just inject the appropriate bits into Asterisk as needed. And it allows you to separate out the system that actually is built on top of Asterisk more from just what is the media engine. And so, again though, from most people's perspectives, Asterisk still looks relatively the same when you're looking at the components. Even though we did a lot of major work in Asterisk, even though there's been a lot of architectural fundamentals that have been changed, we still integrate with all the same things. We still have a lot of the same APIs. They're better. And we still have a lot of the same dial plan applications and functionality. Despite the fact that we've made major changes in Asterisk, we still support everybody who's been with us for the past 16 or 17 years. And that was a fundamental requirement of the work we did, that we had to provide a path for everybody to come along with us. But one of the main reasons why we've been doing this, though, is to try to deal with what I would say are larger systems. This is a very, very bad view of what happens when you start to build larger systems. In most larger systems, you will have a SIP proxy, Kamalio OpenSIPs, that actually deals with the traffic as it comes off of the public internet or whatever your private network happens to be. Use the SIP proxy to load balance. You may use it as a registrar or as a subscription server, but we'll just pretend it's load balancing. And we'll say we're going to load balance between 3 Asterisk systems. Well, those 3 Asterisk systems, with sort of where Asterisk sometimes is, end up storing a lot of state. And that state makes it very difficult to scale, right? I may have application state that exists within Asterisk if I'm using a call queue, an app queue. I may have a lot of state with those registrations are being stored in Asterisk, or the subscriptions are being stored in them. I may also have to establish a lot of communication paths between Asterisk instances. Those communication paths might be used to distribute device state between Asterisk instances. They might be used in order to bridge calls if I have some calls show up on one Asterisk instance and I need to tie them together somehow. I might also have some relatively tight coupling back to my application server. If I'm using AGI or AMI, a lot of times those are servicing 1 or 2 Asterisk instances, and there's a relatively tight coupling between them. It's not easy to build effectively a message bus between things. Well, with a lot of the work that's been done in Asterisk 13, with the ARI API, with PJSIP, we begin to move more towards this model, where you have a network of real-time components with your SIP proxy and your Asterisk servers, but things that make up the business logic, things that define what is the system, now are pulled out from Asterisk, and so it can be scaled better. There's actually an open source project called the ARI proxy that actually creates a message bus with ARI so that you can actually pull out your application logic from the servers that are actually servicing that dial plan application. As I showed with the push configuration, you can now completely pull apart your configuration from the Asterisk instances as well. And that allows you to scale these things more effectively. That leads us to today, Asterisk 14, and where we're going with Asterisk 14. What is the future? So we've talked about the past, we've talked about the present, and now I'm going to make some things up about the future. In my opinion, there's 3 pressures that are happening in the industry today that we see. These are really already here, by the way. None of this is really surprising. We have, of course, the cloud. And the cloud is already here. People are already building cloud-based PBXs, cloud systems. But the cloud does fundamentally change how we view what it means to deploy Asterisk, what it means to scale Asterisk. We have DevOps. What is DevOps? DevOps is a very difficult term to define, but really DevOps, at least in my view, is a breaking down of the walls and barriers between development and operations. And what that means is it's going to change how we deploy systems, how we maintain systems. For example, Gaston's talk on Elk, right, is a perfect example of the implication of DevOps on Asterisk. How do you log? How do you monitor? How do you do this across hundreds of systems simultaneously? And of course, we have the Internet of Things. And what the IoT means is that we're going to start seeing a lot more devices than just what we consider as a phone that we may need to take data from, even if we're not communicating with them. For example, speech recognition can be used to power all sorts of devices. You have companies looking at smart conference rooms, where based on conversations in a conference, they may immediately start a presentation or change the temperature in the room. You certainly see this with call centers, where people might be monitoring inflection in voice and whether or not somebody is emotionally upset, and immediately raise alarms and alerts to supervisors in call centers. And so you start to see Asterisk and what is our communication system becoming part of the entire business, both from infrastructure as well as operations and everything else. All of that is incredibly interesting. It would take a lot of talk, so I'm just going to focus on the first one. The other 2 are probably worthy in their own right, but we'll just talk about the cloud a little bit today. So what is the cloud? The cloud is just someone else's computer. That's all it is, everybody. It's no mystery. So why do we care about it? Well, it's lots of someone else's computers, right? Whereas previously, when Mark first created Asterisk, or even in 2004, 2005, people were talking about deploying systems with 1 or a dozen Asterisk systems. Now we're talking about deploying thousands of systems, right? Over 1,000 Asterisk systems in a network. It does happen. So where we're focused in Asterisk 14 is looking at features for larger deployments, trying to solve the problems that you run into when you're deploying large numbers of Asterisk systems and you need to make these systems play well together. So let's remember this really bad diagram that I had that sort of lays out what you might start thinking about with a large Asterisk system. Well, one of the things that ARI gave us was the ability to pull application state out of Asterisk. That's really helpful because now what makes up the state of my call queue no longer has to be tied into Asterisk. The PJ SIP stack allows you to look at remote registrations, and so I can make my SIP proxy a registrar. And so now I can take the location of phones out of my Asterisk instance. Prior to Asterisk 14, however, there were a couple other pieces of state that still had to live in Asterisk. One of these is SIP subscription state. And so whenever you subscribe for presence, that subscription had to land on the right Asterisk instance. That hurts your scalability. Another one is simply the notion that media has to live on Asterisk machines. And so if I have a customer and that customer has specific prompts for them, I have to make sure that that media gets onto an Asterisk instance and all calls for that customer get on the same Asterisk instance. And so these are both two problems that we wanted to start working on addressing in Asterisk 14. So the first of these is something we call remote extension state. So remembering this diagram, let's say I have a subscription to Alice that lands on one Asterisk instance, but the state for Alice has been generated on the Asterisk instance on the far right. That's bad, because I'm generating state about Alice, but the subscription doesn't live there, and so nobody becomes notified of Alice. What I would rather have is have some other system manage that subscription. Why not Asterisk? Well, because things like Camalio and OpenSIPs have spent a long time working on being very efficient at being SIP subscription servers. So let them be good at subscriptions. What is Asterisk good at? Asterisk is great at generating state. We have all sorts of complex ways to build out hints and little ways and levers to trigger them and manipulate them through APIs. So we're going to use Asterisk to generate the state. We're going to have the subscription live in the SIP proxy. So the SIP user agent can subscribe to the proxy, and the subscription will live there. So we'll have a subscription for Alice. But we'll still have what is a hint for Alice living on Asterisk. We actually even have the ability, because hints are typically generated when a subscription lands on Asterisk, we actually now have a new setting called auto hints that will automatically generate the hints for devices based on the state changes that it sees. And so Asterisk in 14 has the ability to publish state about Asterisk to the SIP proxy in order to update the state. And then the SIP proxy can do the nice thing and send the notify request off to the user agent. Another feature that we added in Asterisk 14. Rather than requiring everybody to push media to specific Asterisk instances so that when a customer needs to hear their prompt, that media had to already be on there, we now support the notion of playing back media by URI. And so this is the problem we're trying to solve, right? I have a media on the Asterisk instance on the far left-hand side, but I've somehow my SIP proxy has put the call on the wrong Asterisk box, and now they don't get their prompt. No good. So in Asterisk 14, you can actually just tell it to play back a full URI. And you can use any RESTful server or anything that supports an HTTP request in order to actually host that media. We'll then go pull the media down. And because this can be something of an expensive operation, there's a media cache built into Asterisk that will store it temporarily on that Asterisk instance. And as long as that temporary file exists, we'll continue to play it back from the temporary file that we put on the Asterisk instance. If, however, we get a playback of the same URI again, we'll prefer to use the temporary file that we created for it, but we'll also check the ETAG field on the remote server. So if you update it, we'll pull it back down and you'll get the new prompt. So there's a caching built in, there's a whole thing to actually go over to the remote playback. And again, this allows you to not have to put all of the media directly on the Asterisk instance. There's a couple other enhancements that we're thinking about doing in later versions of either Asterisk 14 or 15, depending upon the version, where we're going to continue to probably refine this feature. We'll have the ability possibly to push media as opposed to just pull it, because pushing things is sometimes more advantageous. So, other things we're working on. The big thing I want everybody in the room to take away, though, and the reason why I kind of structured this is both a retrospective as well as what we're up to. Asterisk has historically adapted to the technology of the time. When we started it, we didn't have a SIP channel driver. We had voice over frame relay. For a long time, Asterisk was, the Swiss Army knife of telephony. It still is, but, the reality is MGCP, H323, they didn't win. It's SIP. And so we are focused on providing a good SIP experience, and we're focused on providing good APIs to build custom communication applications. The days when people would just deploy Asterisk and just use the dial plan, that's still possible, that's still available, it will never go away. But today, people are building much more complex applications than we at Digium can even dream up. There's some really fascinating things being built. Chris Matthew of Citrix fired a shirt cannon using Asterisk, and I would never have thought of doing that, right? So there's all sorts of things being built today that we can't envision, and so we're trying to provide a good experience for people building systems on top of Asterisk. And we're going to continue to innovate to meet the needs of future systems, Elastics and everybody else as well. Thank you.